The Poisson distribution is a discrete probability distribution that is useful when n, the number of trials is large, p, the probability is small, and the independent variables occur over an interval. For instance, finding the probability of the number of calls a call center gets over a certain period of time, or the probability of the number of accidents at an intersection over a given month, or the number of plants growing per acre. The Poisson distribution satisfies these conditions. Number one is that the random variable x represents the number of times an event occurs over a given interval. And an interval can be length, area, volume, period of time, and so on. Number two is the occurrences are independent of one another. Number three is that the probability for the occurrence is the same for each interval. And number four is that the average number of occurrences over an interval is known. The formula for the Poisson distribution is probability of x equals e to the negative mu times mu to the x divided by x factorial. Okay, let's break this formula down. Probability of x means the probability of exactly x occurrences over an interval. For instance, the probability of 3 accidents over a given month at a particular intersection. The e in the formula is a constant, and it is approximately equal to 2.7183. Mu is the Greek letter, and it represents the mean. Sometimes this formula is written with the Greek letter lambda in place of mu, but both of these represent the mean. And x in the formula is the number of occurrences. So let's look at an example. Let's say that you decide to buy a small nursery that specializes in selling the Stella d'Oro daylily. The previous owner gives you data that says in every planting cycle of 100, 4 of the planted daylilies do not make it and are unsellable. Based on this data, you want to know the probability that more than 4 of the daylilies will be unsellable in the next planting cycle. So this question says more than 4, which means 5 or more. Since you plant 100 daylilies in a cycle, you will need to calculate the probability of 5, of 6, of 7, and so on up to 100, and then add them up, which would not be efficient. Instead, we can find the probability of 0, 1, 2, 3, and 4, and then add them up and subtract that probability from 1 to get the probability of 5 or more. So we know the mean is 4. That was given to us. And using our formula, we have probability of 0 equals e, or 2.7183, raised to the negative 4 times 4 raised to the 0 divided by 0 factorial. I've done the calculations out on the screen, and a couple of things to remember. Any number raised to a negative power is just 1 over that number raised to the non-negative power. So e raised to the negative 4 equals 1 over e raised to the positive 4. And any number raised to 0 equals 1. So 4 raised to the 0 equals 1. And 0 factorial, which we have in the denominator, is equal to 1. So for probability of 0, we get 0.018, or 1.8%. For probability of 1, we have e, or 2.7183, to the negative 4 times 4 to the 1 divided by 1 factorial, which equals 0.073, or 7.3%. And I have the calculations for the probability of 2, 3, and 4 written out on the screen. From here we need to add these up, which totals to 0.629, or 62.9%. We can now subtract 0.629 from 1, which is 0.371, or 37.1%. So there is a 37.1% probability that more than 4 of the planted daylilies will be unsellable from the next planting cycle. Alright my friends, that be the basics on the Poisson distribution. Hopefully this video helped you out. I do have more videos right there for you. Till next time, I am out of here.